Hi, it's Jan Beta, and today is going to be a Commodore 64 repair slash future-proofing thing that somebody won in the Commodore 64 celebratory draw. The thing is, this is the extra draw that I did on my Patreon. And basically the winner of the official public channel draw, Thomas of Acton is his screen handle, didn't get back at me and he didn't answer my messages. The only way I could write him messages was via the YouTube comments section. So please, if you are seeing this, write me an email or at least answer to the comment on YouTube or something so we can get in touch. It's pretty difficult to find out who you are, Thomas. So yeah, basically that's the thing. Or if anyone else knows who Thomas of Acton is, please give him a heads up to contact me so we can work out how to give him his prize, which is the Commodore 64 repair and future proofing. This is going to be the Patreon winner's machine, who is Jean-Luc, and I unboxed this on my Patreon channel, so if you want to check that out, the link's in the corner there and in the end screen of this video. So what I'm basically going to do today is to take this Commodore 64C and at first test it. Of course, it supposedly works, but you can never be too sure. So I'm going to test this. I am going to test the little power supply that came with it. This is one of the later units, so it's a bit better than the old units. It's not serviceable at all because it's potted in resin, but I'm going to measure that and see if it holds up to spec. And then I'm going to recap this and add some heat sinks and yeah, hopefully make this last a while for Jean-Luc. Congratulations again. We wrote some emails back and forth, and Jean-Luc is a really nice, sympathetic guy, and really happy he won. Long-term supporter of mine as well. So thanks for supporting me. Hope this is something nice to give back. Without further ado, let's get into it and do some work on this. At first I want to measure the power supply, because if that doesn't work, basically we are doomed, or this Commodore 64 will be doomed pretty soon. So what I usually do is to just connect this up, and there's a 200 milliampere fuse in there, which is good. It's one of the fused models. There are models that don't have a fuse. It's also rated for 220 volts. That means that's probably, we have 230 volts now, but it's usually fine with these. And yeah, I said repeatedly that these are breaking easily and often. They really do. Okay, so this is one of the power connectors that only has 4 pins. They basically removed all the pins that don't have a function in this configuration. So these are the pins that really conduct electricity. So the pins on top there, under the little notch there, are the AC, and the other 2 pins are the DC. So this should be 9 volts AC or thereabouts, and this should be 5 volts DC. 9 volts AC, 5 volt DC. And the 5 volts should be pretty much spot on, otherwise your Commodore 64 is going to be in danger, because many of the ICs in there are powered directly by this power supply line. So this is now powered on. I am going to measure the 5 volts, which is the more important bit. And it's 5.14, which is exactly what the little 7805 voltage regulator in there should output, which is fine. Now I'm going to switch this to AC, which is probably a bit higher than 9 volts, usually 11 or something thereabouts. It's like 10.7. which is absolutely fine. Okay, usually to really test this, I would put this, connect this to a load and stuff like that. But I'm not gonna do this for this short test. Just wanted to make sure that this outputs voltage at all. You usually would put this a bit under stress and see if the 5-volt line breaks down or anything else goes wrong in there. But I'm not gonna do that. I'm going to put some last resort overvoltage protection in the Commodore 64 anyway, so I'm going to use the Commodore 64 for testing this, and I'm going to keep checking the voltages while it's running, basically. So that's the Commodore 64 is going to be the test load in the end. Which is, of course, like kamikaze, but it's gonna be alright. Now, for the machine itself, it is in pretty good nick. I am going to wash the case a bit and scrub the keys. The seal's already broken. This is one of the later C versions, I believe, made in Hong Kong. So let's open this up and see if we can see anything broken right away. And then we're going to test this thing, which is, of course, one of the more fun parts. So there's just 3 screws in this newer models, and you basically can lift up this, disconnect the LED, and there we are. So I'm not going to show anything really new in this video. I think if you watched my bread bin future-proofing video, this is pretty much going to be the same, except for its different capacitors, and the machine, the board layout is a bit different from the older machines. But yeah, it's going to be pretty similar. I'm just going to change all the capacitors in this, given this works, otherwise this is going to be a troubleshooting video at first. So the keyboard stands on 2 standoffs there, which are held in, the keyboard is held in with 2 screws. The standoffs are held in with the screws that screw down the mainboard, which is this short board, which is a later version of the old original Commodore 64 board that was cost reduced, and it's much shorter. The old board would have reached to here approximately. So there's a little cardboard shield, just like in the older versions, and there we are. So let's remove all the screws and take this board out and then give it a test while we wash the case. From now on I should wear my ESD protection. It's not protecting me, of course, but it's protecting the board and the ICs. So let's just put this here, this one here. This stings a bit. It's probably been stored in a basement for some time, or some storage location, I don't really know. But it appears that the board never was out. Looking pretty good, actually. You can kind of see that the screws come out for the first time, because there's so much plastic residue on there. It's always a good indicator of this. So there we go, there's our cardboard shield. Okay, this is the 250469 revision of the board, which is the short boards. This is the Rev A version, which is, I believe, the middle version. It's not the most recent board, but a refined version of the first version, which was the Rev 3, I believe, that was in the Aldi Commodore. So this machine seems to be from 1989, like summer of 89, I believe. Yeah, the chips are, the latest chips are from July 89. Don't see any bloated caps or leakage or anything like that. It's a bit dusty, but there's nothing seriously going on in terms of damage on this board. There's this little stain here, but I guess it's just It's just surface dirt there that we can just scrub away. Otherwise, this looks pretty good. So let's get the brush and brush it off a bit and then see. Okay, I guess that doesn't look too bad for an initial cleaning. I am connecting a monitor and I am going to connect the power supply and then we can test it. Okay, here goes the first test of this machine. And it totally seems to work. So I have my self-made Datasette / Jupyter switchable test cartridge inserted here, which I hacked together a couple of months ago. The Datasette, as I've repeatedly said, takes a while to start. So there we are. So I'm just going to skip to the end of this test, guess, and alert you if something's wrong. Yep, and it seems to be a fully working Commodore 64C, so let's future-proof it. Haha. So here's what I usually do to these machines. I replace the capacitors, the electrolytic capacitors, which they age. It's just a fact, they do age. Usually they are still good in the Commodore 64s, and there's a lot of discussion whether to replace them or not. My point of view is, if you are using good brand replacement ones, I'm usually using Panasonic or Nichicon or Rubicon caps, or Nippon Chemicon or Europe Chemicon, good renowned capacitor brands. You are always going to win, I guess. Because these are old, these are from the 80s, in this case end of the 80s, and they have a limited lifespan basically. They have a limited life. That's why I am using good capacitors, so they are good for another couple of decades probably. I am also, that's not a must, I am going to replace the little bridge rectifier that's in here, because I've seen them fail. What this is basically a couple of diodes that rectify the AC voltage that goes in here to use it for various parts of the circuitry as DC voltage. So this goes away because I've seen it fail in Commodore 64 and in VIC-20, and these are pretty flimsy and they do age and fail like diodes fail and age. Yeah, I am going to heat sink some of the chips, especially the VIC-2 chip and the SID chip. I'm also going to put one on the processor, in this case I guess. I will clean the fuse solder here because I've seen these fail a lot. Yeah, that's basically what I'm going to do. There's no voltage regulators in here like in the breadbins. The voltage circuitry is done by some little Zener diodes, and it's a more modern circuit that's pretty much more reliable than in the old ones. So the voltages are more stable and there's not so much heat building up in these anyway, but there's still heat emitting from the usual suspects. MOS chips like the SID and the VIC-2. The PLA is integrated in this chip, in this case made by Sharp, which is indicated by the little S there. They are usually running way cooler than the original PLA chips, which were pretty hot. So, anything else to say? I'm also going to desolder this one and change the capacitors in there, because I found that it improves the picture on the composite out, because the composite signal is generated in this little RF modulator, which is there for connecting a TV through an antenna cable and tuning into the right channel, and you get the picture from the Commodore 64 there, and the sound, apparently. So what this does, the circuitry in here is mixing the composite signal too, so that's usually giving a bit of improvement to the overall picture quality. So, okay, I am changing one capacitor at a time. I am going to make sure to get the polarity right, especially on this actual capacitor, which I got wrong when I future-proofed my Commodore 128, and I thought I broke it by that, but it was something completely different in the end. But yeah, it was quite an adventure. If you want to follow that, you can watch my future-proofing video of that. That was where I put a capacitor in backwards. Yeah, it happens to all of us. So yeah, that's what I'm going to do, and I'm not going to talk much during that. And yeah, using my trusty desoldering station, which I still recommend, by the way, cleaned this up for today. You have to clean this pretty often, so it works well every time you need it. That's the only thing you need to do. So let's future-proof this thing. Okay, let's stop this montage. I just encountered something that is new to me, which is that this can that holds the RF modulator is actually soldered to the board from the top side. I desoldered all the pins on the bottom side here, which is these are the contacts, the lines that go to the main board, and there's these little metal latches that stick through the main board and they're just turned to release, soldered on. And then there's this corner here soldered on, which is new to me. You've never seen that. So I'm going to desolder this here, hopefully. And then we're hopefully going to make contact to the board there. And actually says Commodore 128 PAL, which is kind of funny. So these were probably the same RF modulators that they used in the Commodore 128. Interesting. And I usually leave a bit of text under the RF modulator if I replace it. So nobody's ever going to see this again, probably, but who knows? Okay, I got all the capacitors replaced now, including the ones in the RF modulator, as you've seen. And yeah, let's give this a brief test before we add the heat sinks, I guess. Here we go. Yep, and luckily it still seems to work. Okay, let's add some heat sinks to this thing and then put it back into the case and finish this. So I nearly forgot the suppressor diode. That is the crude overvoltage protection I was talking about earlier that I want to put in here. And here's where it goes on this mainboard revision. I'm going to link this PDF. It's a German PDF with locations for the suppressor diode in it for various mainboards. You can see it on the left side there. I'm gonna link that in below. This is page 24 of the document if you want to play along at home and don't understand German. So I'm gonna link that PDF. There's a lot of nice informative stuff in there considering the Commodore 64. So here's where you put it. These two little pads here are where the diode goes. Maybe it was even planned to do a diode thing there. I don't know. And the negative goes here. So I'm going to put a little minus there. So that's our negative where the ring of the diode goes. So the diode we're using is I'll show you this, P6KE 6.8A, which is a transient voltage suppression diode, 6.8 volts. What it does basically is it starts conducting when it reaches 6.8 volts and above. So this is going to be soldered across the negative and positive rails of the 5 volt supply. And when it starts conducting, it basically shorts the 5 volts out to ground. So there's no 5 volts going into the mainboard and your computer is safe just in case your power supply misbehaves and puts out too high a voltage. This is very crude because the power supply is going to be shorted, so there's going to be some stress on the power supply, but it's going to be done with anyway if this happens, and probably the fuse is going to pop at some point. What it does is to protect the chips from getting any damage because they usually can take up to 7 volts for a bit. Some of them survive higher voltages for briefly, but you won't have any luck if they are getting voltages above 7 volts for longer. So that's the absolute last line of defense, so to say. But I'm going to add it anyway because these are not very expensive and I like the idea of having another layer of protection in there. Okay, adding some heat sinks. I recently bought a big bag of heat sinks, so I have enough for these refurbishments. So I washed the chips with some alcohol to remove any fat so the little pads can stick better. And I think I am going to leave the cardboard RF shield out as I usually do because it's merely for FCC compliance from back in the 80s. I don't know, I don't even know if the rules are still the same. So there we go. That's heat sinked and ready to go back in the case when the case is dry. So I'm not going to take apart the keyboard because it looks in pretty nice condition. I am going to take a brush to it and I'm going to remove the dust here. And then I'm just going to go in with some alcohol and scrub it a bit with the brush. And I'm going to use my toothbrush for this because that's the cleaning brush. The other one's for circuit boards. This one is my brush for case parts. Can use an old toothbrush, or you can have a dedicated toothbrush, which I did. Toothbrushes are not expensive. And you don't get the dirt from your teeth onto your old computers. So I highly recommend getting a dedicated toothbrush for doing stuff like this. But usually that's pretty much enough for cleaning a keyboard. You get into the cavities pretty good with the toothbrush. And if you pay attention, you basically can get to nearly everywhere without taking the keyboard apart. Repeat until you are satisfied with the results. But this one was pretty clean to start with, so nice. And it's not very yellowed. It's a bit light, very, very slight tint of yellow, but it's really okay. It looks almost new. So the rest of the case is getting a treatment with a big brush and some window cleaner and probably some usual soap. So let's do that. Okay, I am going to let this dry, and it has some yellow streaks here, I don't really know why, that don't wash away. Strange kind of yellowing, maybe this was sitting under a dust cover or something, and this was the only part that's yellow because it was sitting in the sun, maybe so. So I had this run for an hour or so, and it still works, and it's not getting too hot at all. And the chips we heat sinked are the chips that are getting warm, so that was the right decision. Yeah, let's put it back in the case. So there we go. Doesn't look too bad to me. And as I said, the protective film is still on here for Jean-Luc to remove himself. Because that's gonna be pretty satisfying, I guess. Yeah, it doesn't look quite as new because it has some yellowing on the side here, but it's very, very, very subtle, so this looks pretty good. Okay, so this is not working as nicely as expected. The L key seems to be broken. Nothing happens. Let's see if the other keys work. The right part of the keyboard, some of the keys don't work. So maybe it's just something with the connections there. So I have to open this up again. So this is going to be a bit of a repair after all. Okay, the first step I want to do is to clean this connector again. The keyboard connector on the board here. And then I'm going to spray some contact cleaner into this connector here. Maybe something got in there or something like that. Take this away so I don't spray the insides of the confuser. Okay, let's try again. Fingers crossed. Okay, it seems to be the L works, the P works. Seems to have been just a broken, dirty connector there. Yeah, no, it absolutely works. Okay. Whew. That wasn't much of a repair, but I'm just glad it works. The Commodore 64 pack also came with this, which is a C2N Datasette, which is a bit roughed up on the edges, but otherwise looks quite good. If you have these things on your plastic, especially on retro computers in this case, that look a bit like battle scars, they are actually from the cables being wound around the things, and in the cables there's chemicals that make them soft. And basically if you put the cables around these things, the chemicals slowly can get out and make this plastic soft, which is not supposed to be soft, obviously, and then melt it chemically. So that's what happens there. So this is how to store your cables, always away from the things. I would have preferred not to store it with a rubber band like this, but to make a wider circle so there's no danger of breaking leads in there. Yeah, but that's how these things happen. So what I usually do with these is to give them a quick mechanical test and then get in there and clean the head with some IPA, which is isopropanol or isopropyl alcohol, and a cotton swab or a cotton bud. So I'm just going to spray some alcohol on here. And I am going to gently wipe down the head. There's one erase head and one read-write head. So there actually is some dirt coming off there. Nice. Okay, let's see if this dataset still works. Doesn't do anything. Okay. Okay, so here's why this thing doesn't work. I don't know if you can see it very good on camera. Here's the contacts. These are all on the front there. And there's one that's actually, it's pushed in. So you can see it better if I hold it like this. This one here, I'm pointing at, is pushed down there. So I really have to get it to the front here, so it makes contact at all. So I think there's just a little Phillips screw here. Yes. Okay, now we should be able to open this. Yes, we are. This shield isn't connected I think for newer revisions of this, so it doesn't matter much. So there's our contact. So I'm going to clean this while I'm here and push it back in. Now it's in, okay. It just snaps into place there, okay. So what I'm going to do is literally just put some hot glue in the way of the wires here. So they're going to be held in place by the hot glue. Ta-da! Put in more hot glue here. Yep. And I managed to not glue myself all that much to the connector, which is good. I mean, who wouldn't want to be connected to a Commodore 64 dataset forever? Yeah, really not me. But let's see if this helped. Okay, found something. But that's probably not, yeah. Okay, this seems to be misaligned at the very least. So let's try and align this with my usual tool set. It seems we fixed the connector at least. So I'm loading my azimuth adjustment tool here. And I'm just following the instructions basically. The adjustment screw is located in this hole. Basically you adjust the tilt of the read-write head with a small Phillips screwdriver like this, and you basically adjust it for solid lines. It should look something like this. This looks pretty good. And of course you take, ideally you have an industrially recorded tape, so the tape was recorded on a well-aligned machine. So okay, I got this aligned halfway. It should probably work. Let's see if we get anything now. It should, after pressing play, it should find the file and then commence loading it. That's much better. That's how it's supposed to be. Okay, the tape was just misaligned probably. Let's see if we can load Galancia in full. I'm probably going to jump cut a bit. Oh, it's finished loading. Okay, press space. Okay, so this thing seems to work. Nice, that's Galancia. This Commodore 64 and the Datasette seem to be working now. I'm going to send this off to Jean-Luc. Congratulations again for winning this, and I hope this lasts you a long time. Okay, anyway, hope you enjoyed this. I certainly did. I always enjoy working on Commodore 64s. And the only thing I'd recommend is to get a new power supply for this, one of the modern replacement ones. It doesn't really matter which one, they are all better than the original one, I guess. Haven't tested many, I made my own. You can do so too, it's not that difficult if you have basic knowledge of soldering and working with electricity basically. So yeah, everyone else, thanks for watching. Hope you stay tuned for more videos on this channel. A lot of retro computing stuff coming up soon. If you want to give me some support and in return watch some behind the scenes stuff and some outtakes and some vlog stuff, check out my Patreon. I'm going to link that in the corner there. Yeah, thanks everybody. See you all soon. I'm Jan Beta. Thanks for watching. See you next time. Bye. Now for the machine. Whoop. Okay. Let's do this again. Just need to untangle this a bit. Okay, let's add some heat things. Okay, let's add some heat things.